Hello friends, welcome to Shiksharthi. In this video, we shall be discussing the basics and concepts of time, distance and speed. So let's start. Now in this video, we'll be focusing on the concept of relative velocity. And as of now, we'll be talking about linear concepts of relativity, which is relative velocity. Okay. Now we are already aware of the fact that now why are we using a term like relative velocity? Because when we are using the concept of velocity, the direction of motion is very important, which is why we are not talking about relative speed. Though if I want to use a term like relative speed, what we can do here is, along with the speed, we can talk about the direction, which ultimately converts the discussion into a discussion on relative velocity. Okay, so now let us say that there are two individuals or there are two bodies A and B. So here we are talking about entities. So let's say we are talking about two entities A and B. Now when we are talking about relative velocity, we can talk about two entities to start with, or we can talk about three or more. So the point that you need to understand here is the concept of relativity, which is relative velocity, is applicable to number of entities which are 2 or greater than 2. This is the first concept which needs to be understood. Second, relative velocity, the concept of relativity or the concept of relative velocity is a pseudo concept. Now when I say it is a pseudo concept, that means this works in non-inertia or non-inertial frames. Now when I use a terminology like non-inertial frames, what I intend to convey here is, before that, I mean when we are discussing non-inertia, we need to talk about inertia. So what is inertia? Inertia is a property by virtue of which a body tends to remain in the same state unless an external force is applied on it. For example, if you have switched on a fan, so the fan starts working, it starts rotating, unless an external force is applied which makes it stop. Similarly, there is an object which is stationary. Let us say that there is an individual who is standing, a boy who is standing, and suddenly he's made to move. How? There is somebody from the back who comes and pushes him forward. So that also is non-inertia, or should I say inertia? Now when we are discussing inertia, we'll talk about inertia only. So this was an example of inertia, wherein a body tends to remain in the same state unless and until an external force is applied on it, which changes its state. Right? So the moment the state changes, in that case, it becomes non-inertia. For example, throwing further light on this, so if there is a moving body, so if a moving body is made to stand, or a body which is at rest is made to move, these are some examples of non-inertia. And an example of inertia would be a moving body will keep on moving, and a body which is at rest will keep on remaining at rest only. So the concept of relative velocity is applicable only when we talk about when we talk about non-inertial frames. I'm putting the heading here so that there is no confusion what are we discussing. Third, now once we know that the relative velocity, the concept of relative velocity is applicable to two or more entities, and then we are talking about non-inertial frames, the third thing which is important here is this concept is applicable when we consider the motion of the bodies or of the entities or when we consider the motion of the bodies beginning at the same time or starting at the same time. Now this starting at the same time or beginning at the same time is very important. Fourth, then we talk about the direction of motion of the bodies or the entities concerned. So these are few points which are important when we talk about the concept of relative velocity. Now, when we are talking about the direction of motion, so let us say if there are two bodies moving in the same direction. So this again will be divided into two parts. Same direction, opposite direction. Okay, so now when we are talking about two bodies, we are talking about the A part first, moving in the same direction. So the relative velocity, let's say, this is how we represent. There are different representations. So here we are saying A with respect to B will be nothing but VA minus VB when they are moving in the same direction, and this formula itself speaks because the direction is the same. Now generally it is understood that we take this generally, though we can divide this further into two cases wherein this VA minus VB will be positive. So here when we are talking about VA minus VB, which is the relative velocity, this may be positive, this may be negative. Now when this is positive, in that case we have considered this, but if it is negative, in that case we have considered this. Generally we talk about this only. We can talk about this also, but it is suggested that you talk about the relative velocity when the slower paced body is made to come at rest. Now, so how do we project this? How do we make you understand this? Is just like saying, can I say that the relative velocity here, VA versus B, is nothing but just like saying, since I have to divide it into two parts, I can put it as this is VA minus VB plus 0. Now what does this indicate? This indicates that I have put the velocity of VB, VB here is made to come to rest as we were talking about, and now it is only the differential velocity with which the faster paced object or the entity was moving. So the last point which is important here is, the last point, which is fifth point, is we put the slower paced body to rest. This is important here. So which I have already discussed, but I am just extending it here so that you are able to understand it in a better manner what is. So what do we do here? Let's say if there are two bodies, two objects or two entities, let's consider them as objects. Now if both of them are moving at the same pace, the concept of relativity misfires, because then what are we using this concept for comes into picture. We are using this concept to ensure the time taken to cross, the time taken to collide, the time taken to meet, the time taken to overtake, all these things, or all these these kind of questions have to be answered with the concept of relativity, which is a pseudo concept. But if there are two objects which are moving at the same velocity, this concept misfires is because then there is no overtaking when we talk about the same direction. But when we talk about the opposite direction, yes, we can always talk about they would meet when, they would collide when, they would cross each other when, if they continue to move. Right? This is how the questions are framed. So coming back, theory of relativity says the slower paced body is put to rest and the faster paced body now moves with a differential velocity, and that differential velocity is the difference between the velocities of these two objects. That is how you use for two objects which are moving in the same direction. Now when we talk about two objects moving in opposite directions, this is how you would represent it. Now when you're representing it like this, and you know now this can be converted into another direction also. For example, if I want to change the direction, what is going to happen here is I'll have to use a minus sign. So in a certain way you are using coordinate geometry, or anything for that matter of fact. If I have to represent plus 2, I can represent it as minus of minus 2. So can I rewrite it as this is nothing but VA plus VB now. So you have converted this into the same direction. Now when we are talking about two bodies moving in the same direction, in opposite direction is what we are talking about. Please try and understand this opposite direction can be divided into two parts. One is, are they moving towards each other, or are they moving away from each other? This is very important. So when I am saying they are moving towards each other, this is what I mean, and when they are moving away from each other, this is what I mean. In either of the cases we are talking about they are moving opposite to each other. So the formula that I am using here is, we are using this for there are two objects which are moving towards each other, because what is the object? What is the objective? The objective is to ensure when would they meet, when would they collide, when would they cross each other, etc., as I was talking about few minutes back. Okay, so once we have done this, now we can use the same logic here. So what are we using? So if I am saying relative velocity of A with respect to B, it is assumed that B is slower paced, or I mean maybe, now since we are talking about opposite direction, so maybe they are equal paced. So now, so here you need to understand this. So this gets divided into three parts. So when we are talking about this, so there may be a condition that VA is greater than VB. There may be a condition that VA is equal to VB. And the third condition here is VA may be lesser than VB. Is what we are discussing here, as we had talked about here. So this case becomes redundant here, because if they are moving in, if there are two objects moving in the same direction, let them move in that case. Then why will we talk about who would overtake each other? They just can't overtake each other. So even if they are made to start together from the starting point remaining the same, then also, I mean, if their starting points are the same, so you will see now more variables come into picture. From where did they start? Did they start from the same starting point? Did they start from a different starting point? Is how you would reason out the concept of relativity. So relativity has nothing to do with whether the starting points were same or not. But what it has to do with it is from wherever it is starting, whether it is starting from the same point or they are starting from a different point, but they should start at the same time. That is important. Okay, so we were talking about how will we represent this if I have to represent this in this format. So this is how you would understand this. So you put one body to rest, and it is the other body which moves with that differential velocity. Now the differential velocity here is VA plus VB because they are moving towards each other, and here the differential velocity is VA minus VB because they are moving in the same direction. Right? Okay. Next point now here which is important here is, so let's say point number 6. So we use a terminology like time taken to meet, time taken to collide. Collision also is a type of a meeting only. Time taken to. So I'm just writing some synonyms here. So maybe time taken to meet could be time taken to cross, time taken to overtake, time taken to collide, etc. This is the definition of meeting. So when we are saying time taken to meet will be, so I'm using a capital T, though we are aware of the fact that we are supposed to use a small t. So time taken to meet is what? Will be displacement divided by, so relative displacement. So let's say relative displacement divided by their relative velocity. This is how you would work it out. Now what do I mean by relative displacement? So as I said, relative displacement here would be maybe their starting point is the same, correct? Which is, so if the starting point is the same, and now we are talking about when would they meet the next time, because they have already met for the first time because the starting point is the same. Now in that case, if I am talking about linear, because we are discussing linear relativity, so in that case let us consider the case wherein they are moving in the same direction. So now if they are starting and if they are moving in the same direction, the concept of when would they meet gets defeated because their starting point is the same, right? I hope you are understanding. So there is a difference that needs to be created. Now how will I create that difference? That difference can be created only when I say, okay, let the first fellow go, which is moving at a slower pace for some kilometers or some meters or for some unit of a distance, and then we can allow the faster paced person to start, so as to gauge when would they meet after some time. I hope you would have understood this. Or then we talk about trains moving on the same track, trains moving on a different track, wherein the relative displacement in that case becomes, so now we are talking about special case like trains, wherein the displacement, the relative displacement becomes nothing but the distance of separation. So let's say the length of A plus the length of B plus the separation between them divided by their relative velocity. So let me use this. Now this relative displacement has nothing to do, let's say if I take an example of trains, whether trains are moving in the same direction or they are not moving in the same direction, in any case the relative displacement would remain the same as the length of the first train plus the length of the second train and the initial, let's say the distance of separation between them, keeping their direction of motion constant. Because the moment I use a word like distance or separation, along with that I am talking about the direction also, which makes take care of the displacement part. So I hope you have understood this. Next point here which is important here is, so the same concept when we talk about boats and streams. So when we are talking about boats and streams, we talk something like upstream, we use a terminology like upstream, or we use a terminology like downstream. Now the terminology upstream means what? Against the flow. Now flow of what? Against the flow of stream. And this is downstream is with the flow. Now when you are saying with the flow, you are basically talking about with the flow of the stream. So let's say if I am talking about upstream velocity, now upstream velocity is against the flow. So let's say this will be VB minus VU because it is against the flow. And the downstream velocity will be VB plus VU. And why is this greater? Is because of the fact that you are flowing, you are flowing along with the flow of the stream. So your net velocity increases, but if you are flowing against something, your net velocity decreases. Now I can use these as two equations and then I can find out. So let's say now, so in that case equations, they play an important role when you talk about time, distance and speed, along with other chapters which I have talked about in my other videos. So here I can calculate the velocity of the boat is how much. If I subtract this from this, is just like saying VD plus VU and half of this. Similarly, the velocity of the stream is VD minus VU divided by 2. Now if you think in a certain sense, this is just like we are talking about escalators. And let's say a moving platform. So when you say that, let's imagine the case of escalators. So if I'm using an escalator in a mall, in that case, when you step up an escalator which is going up, so in a certain way, it becomes what? Downstream movement, because the time in which let's say that you stop the escalator. Let's stop the escalator, so it becomes a manual process. So if I stop the escalator, in that case, the entire effort has to be applied by me only, which will take some time to reach to the top from where I am at the bottom. But now let us say if I start the escalator and there are two things which are moving at the same time. There are two things which are moving. One is me and the other one is the escalator. In that case, the effort that I need to exert to reach the top is lubricated. So let's say it's fulcrumed or whatsoever. So in that case, the time that I would take now to reach from where I am at the bottom to where I am supposed to go at the top would be reduced, because there are two objects which are moving in the same direction and they are facilitating the move. One object, let's say, is facilitating the move of the other. So when I am using a word like downstream, downstream is a process of facilitating. And when I say upstream, it is a kind of non-facilitator. A non-facilitator here could be a neutral fellow or could be an inhibitor. Here when I am using a word like non-facilitator, by this what I mean is an inhibitor. Inhibitor is which thwarts your flow. So now the same thing is, let us say that there is an escalator which is coming from top to bottom. And now instead of using an escalator, and now you want to go to the top, and absent-mindedly you embark on this. Absent-mindedly. So mindedly, why would you want to embark upon something which negates your motion? But absent-mindedly, let us say that you climb on an escalator which is coming from the top to the bottom, right? So in that case, what is going to happen is, it will take you a lot of time to reach to the top, and it puts you also to a health hazard. Maybe you fall down. And why is this happening? Because first of all, you are working in non-inertial frames, let's say, because from your side you are trying to apply inertia, but from the other side there is an equal and opposite force that is being applied on you. But anyway, let's forget about the physics part for the time being. But in this case, now you will see that you are trying to reach the top, and it takes you longer to reach the top because there is an upstream movement. Upstream is an inhibitor or a non-facilitator. So the concept of escalators also would remain the same. I hope you would have enjoyed whatever we discussed in this video. Now, if you feel that this video is really knowledgeable, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get regular updates from us. If you want us to do videos on specific topics, don't hesitate, put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.